Hi, this is the Team Rush LabVIEW cRIO robot project video. So, if you have not seen our setting up LabVIEW video, please see that to get the latest updates and make sure that your LabVIEW is running fine. So, once you open up LabVIEW and it looks like this, you're going to go to FRC cRIO robot project. Go ahead and click on this, and you're going to give it a name. We're just going to name ours Team Rush Test. And then the next thing you're going to have to do is change your cRIO IP address. Since our team number is 0027, we're just going to set our IP to 10.0.27.2. Or if you were a team like 1234, you could just set it to 10.12.34.2. So once you've set up your IP, go ahead and say finish. And it will take a little while to get it running, but once you do, you're going to have your Project Explorer. Now you're going to go to robot main. This is your main part of your code that you're going to be using. It's the overarching file. So now once you have loaded all of your sub VIs, you're going to open up this. Now what I would recommend is learning some of the shortcuts. So the very first one, we're on our front panel and we want to go to our block diagram. Go ahead and hit Control E at the same time and it will open up our block diagram. Now this is the actual coding part, and our front panel is more of the visual control side. So now we're going to go into begin. This is where all of the variables are initialized. So go ahead and double click on it and it should open. Hit Control E. And now we have our VI. Now the first thing we're going to do is we're going to go ahead and clear out the existing drivetrain. So we found out that the typical WPI robot drive was actually taking away from the ability from our driver to use full control of the robot. So we are going to initialize our drivetrain like a normal motor. So if you right click and you open up your functions tab like this, go down to WPI robotics and you'll find motor control down here. So our first thing that we're going to have to do is say open. Since we have talons on our robot, we're going to have to set it up for the talon. And we're also going to have to point it to an I/O port. So to do that, you're going to right click on the input right here where it says digital module, and we want to make sure that it's on our digital module 1. And then we're also going to have to set its PWM channel. So just right click on it and say create a constant, and we have it plugged into PWM for our left motor. Now we're going to have to do a refnum set. So then if we go back to our WPI robotics library, robot drive, advanced, motor control, we're going to go to refnum set. This is telling our code that we have a talon plugged in here and its control device name. So go ahead and plug in your error in and your device reference, and we're also going to give it a name. So again, wait for your little wire to come onto this node, right click on it, go to create constant, and we're going to give it a name. So we're going to go ahead and name this left drive. Now it's important programming to keep all of your variables one name and to separate your words by starting them off with a capital letter or doing an underscore to separate them. So right here we've just set up our left drive, and we want to do the same thing for our right drive. So we're going to go ahead and copy this whole thing and then go ahead and paste it over here. Now our right drive's plugged into PWM2, so we're just going to click here, switch it to PWM2, and then we're also going to have to rename our variable name to right drive. Now, since tank drive is driven kind of like a bobcat or zero-turn lawnmower, we're also going to need to have two joysticks. We're going to copy our joystick 1, copy that, and paste it over here. Now since we have it plugged into another USB spot, you're going to have to go to USB 2. And we're going to name this joystick, or we're actually going to rename these joysticks. So this is going to become our right joystick. And we're also going to rename this one to left joystick. And we're all done in our begin VI for right now. So go ahead and close out of our begin. Make sure to save it. Now the next area we're going to go into is our time task. Go ahead and open up this. Now since we aren't running any code in here right now, I would advise running all of your sensors inside of time, or your periodic tasks or time tasks, so that you can read it also in Auton and in Taliop. So since we don't need our joystick or our motors, we're going to go ahead and delete all of this. Now since we have some errors, go ahead and hit Control D, and that will clean up your wires. And go ahead and delete these unneeded ones here. Now if you want to run a task every 10 seconds, you would put your code in here, or for 100 seconds you would put it in here. But for right now we don't need either one of these, so I'm just going to go ahead and we're going to go and right click, go to structures, and go to a diagram disable structure. Everything inside this structure will be disabled, so this code won't run, but I didn't want to delete it because we might need to use it later. Now the only other thing that we have down in here, and never mess with this, this is for your LED status light that you will have on your robot. This is what lets the field know what your robot is doing and what mode it is. So leave this be and it will run. Again, we're going to go ahead and close and make sure you save. And then we're going to go into our autonomous mode. Now there's a bunch of stuff that they already have pre-programmed in here. This is how they're showing it on the dashboard, or the values to the dashboard, and we're not going to really need this for right now. So we're just going to go ahead and delete everything that they already had in here because we don't need it right now. Now when you program in Auton, it kind of goes in a sequence. So you drive forward first, and then you turn, and then you shoot. But everything goes in a sequence. So we're actually going to right click and go to structures, and we're going to go into a flat sequence structure. So everything will run in this sequence structure once. So then what we'll need to do is we'll actually add a frame after. So then everything that runs in this code, then once this code's done, it will go into over here. So the first thing that we're going to do is we're going to run our right and our left motors forward. To do this, we're going to go here, and we're going to right click, go to WPI Robotics Library, Robot Drive, Advanced, Motor Control, and we need to get our refnum get. This calls back to where we said in begin, this is where I define my motors. So go ahead and click here, and to save a little bit of time you can just right click, go to Motor Control Palette, and we're going to go to Set Output because we want to set the output for these motors. So go ahead and plug in your error in and your device reference, and we're going to have to go to our refnum name. These are what we call our motors in our begin. So we're going to go right click on that node, go to constant, and then we're just going to move this a little bit up and out of the way, and we're going to name this left drive like we did in begin. So this references to PWM1. Here's our left drive, and we're also going to do the same thing but for right drive. Now I want to give full control to the motors. Now when you're setting the output for the motor, it's anywhere between -1 or 100 and +100. So right now I want to run them both motors at 75% power, so it'll drive forward fairly quickly. To do that, I'm going to right click on our output, say create constant, Now, this is what's called a double. A double is nice because it can have a float point. So the difference between an integer and a double, an integer is a whole number, but a double allows you to have decimal points. So you can fine-tune it and get more precise. But for a motor control where you have between -100 and 100, 0.5 really won't make much of a difference. So we're going to hook up both of our outputs to this, and we're going to give it our 75% power. So type in 75. Now I want the left and right drive to drive forward for 3 seconds. And to do this, we're going to right click, go up to timing, and we're going to go to our wait millisecond. Now it's important that I said millisecond because it's not in seconds, which will alter your time drastically. So then go, wait till your cursor highlights milliseconds to wait, right click, go to create, constant, and since I said I wanted to go 5 seconds, we're going to type in 5,000. This way, the robot will drive 75% power forward for 5 seconds. And it will run this code until it's done. Then, it will go into this next sequence. And this is where I want the robot to turn. So I'm going to go ahead and copy in our left and our right drive, bring it over into here. But instead of sending 75% power to both, I want the robot to turn to your left. To do that, we need to give positive voltage to the motor on the right and negative voltage to the motor on the left. To do that, you're going to go up to numeric, go to our negate, and we're going to go ahead and plug it into our output. So it's going to send 75% power to our right, it's going to send 75 until it gets to this block, and then it will send out -75 to our left. Now we don't want it to turn for long, so I'm going to have it turn for a half a second, so 500 milliseconds. So this is our drive straight, and this is our turn. Now you can also add additional frames here at the end if you need to, but for right now, we should be all good. Go ahead and close out of this. Out of this, make sure you save it. Now we're going to do the same thing in our teleop. So open up teleop, go ahead and open, and we're going to go ahead and delete everything again, except for our joystick 1. So since we're using typical flight joysticks, the y-axis is your what moves it when you move it forward and backwards, not left to right. That is your x. So we're going to go ahead and rename this left joystick, like we did in begin. We're also going to do something similar to what we did in the autonomous mode, where we set up our motors. So we're going to go back to our WPI robotics library, robot drive, advanced, motor control, and go to our refnum get. This is what talks back. Go ahead and right click on this, and we're going to say constant, and we're going to name it our left drive. Next, we're going to also have to get set our voltage, so we're going to go to motor control palette, go to set output, go ahead and plug in your device reference and your error, and then for our output we're going to go ahead and plug it into our left joystick. Now all the way forward on the left joystick is 100 and all the way back on the left joystick is -100, which is also the same range for our motors. So we're going to go ahead and copy our left joystick and left drive code and paste it, and then we're going to do it but for our right joystick and our right drive. This is all you need to get the simple robot running. If you need to add another motor, we can go back into begin and simply do what we did here for our left and our right drive, but you can go ahead and rename it to whatever you would like, maybe the motor name or what it does. And then you're also going to need to change your PWM channel and also what type of motor controller it is. So once you're done with all of this, go ahead and you can close it all out. Make sure you save your robot main, save all, and you should be good for right now.